Let's have a look at some more momentum questions here that get a bit harder. So you could be asked to do questions where there's a bullet, say, travelling sideways here with a mass of maybe just 2 grams and it's got a speed of maybe 300 metres per second. We're going to collide that into a block of wood here that's stationary on a smooth table with a mass of, say we'll give it 5 kilograms. And the bullet's going to embed in here and knock the block forward after it collides. So what we're interested in is how fast does this combined object now go after the collision. So you would still use the same technique here. And the technique you use is LOCOM. And LOCOM, don't forget that says the total momentum beforehand as a vector is equal to the total momentum afterwards. So you need to look at how many objects you've got to start with. Well, to start with, you've got 2 objects. You've got a P1 and a P2 there, and you could use subscripts here, by the way. So if I replace this with P of the bullet and the momentum of the wood, afterwards you've got one combined momentum of the block and the wood together. That's the situation you've got here. 2 objects becoming one there as a momentum. So the first one here, you've got a mass times velocity there. And here, the momentum is 0 because it's not moving. This is stationary to start with. And afterwards, we've got to combine one other combined mass here. It's 2 masses that you've got to add together then. And that's been multiplied by the final velocity there. Okay? So looking at that then, you just need to substitute the values. So what we've got here is 300 for the speed, the velocity, going to the right, with no momentum, so you can ignore that. And it's got a mass of 2 grams, and that needs to be converted to kilograms, so you need to divide by 1,000, so it would be 0.002. Or you could write it as 2 by 10 to the minus 3 as well, which most people do, especially if they're getting into year 12. So let's have a way of writing that. On the other side here then, you've got a mass of the bullet there of 0.002 plus the wood, which was 5 kilograms. So you've got to consider this to be 0.002 plus 5 kilograms. So you can put that down as 5.002 there as a total mass. And there's the velocity. So to solve for this then, to find out what the velocity actually is afterwards, all you need to do is divide through by 5.002 because it's being times here. So we're going to multiply these together and then divide by that. So multiplying these together, you end up with a number of 0.6. Going to the right, we're going to divide by 5.002. And that will give you the B dashed. Alright, so the answer will be to the right. Now say you get 0.12 metres per second going that way. So you can see the bullet's lost a lot of speed because most of its momentum has been transferred into that block of wood. The other sort of questions you could be asked is if you've got something like a truck coming in one direction there, coming say east, so we'll give the truck a velocity east of maybe 20 metres per second. And we'll give it a mass here of 3,000 kilograms, 3 tonne. Alright, that's travelling east, and we'll have a car coming in north here, terrible car, sorry, with a mass of 1,000 kilos and a velocity north of, let's get back 30 metres a second. Now if these two collide and stick together, and it was on a wet road, which way would they go after they stuck together? Well, if you look at these 2 vectors here, the total momentum is coming sort of that way. So we're expecting them to go this way here, but we need to be more exact than that. To solve that problem, what is their velocity afterwards? What would we do? So you use exactly the same process. So stick to your processes there and be confident in it and just work through it. We expect that due to the law of conservation of momentum, the total momentum beforehand should equal the total after. So go through that same process again and identify what parts you've got. Again here you've got 2 parts beforehand. You've got an NV going to the right. You could call it truck here if you wanted to, or use it 1. And momentum of the car is going north. And afterwards we've got one combined mass now again, giving one combined velocity afterwards. That's what the dash is for. So all we're going to do here then is actually substitute. So you've got 3,000 times by 20 there, going right, plus 1,000 times by 30 going up equals, now the total mass here is 1,000 plus 3,000. So put that in as 4,000 straight away, V dashed. All right, so what you've got here is 60,000, right, plus 30,000 up is equal to 4,000. So the numbers have got larger, but it's still the same process. Now from here, some people make the mistake of going, this is 60,000, 30,000, 90,000. But that's ignoring the fact that the dimension is a vector. This is going to actually go this way. We pushed off in that direction, as we said, so we need to find out what that would be. So to do that, we need to do a vector diagram. So you can do that to one side if you like. What we're really doing here is just finding out 60 in one direction, 30 going that way. What would it be doing as a total from start to finish with an angle? So for this part here, we'd be doing the square root of 60 plus 30 squared. I'm doing this in thousands basically. And if you do that on a calculator, it's the square root of 4,500. That's 67. So we were doing this as 67,000 then, going back to the thousands, in this direction here. And we need to then sort of solve that here. So what you're going to do here is do 67,000. To get rid of this times by 4,000, you're going to divide through. So V dash would be the 67,000 divided by the 4,000. You can see the thousands will cancel there, you get 67 over 4, which is about 33. It's about 16 and a half, just over 16 and a half, so 16.7 meters per second. It's about that from the checker. We should give the angle here though, for both those situations. So it would be 10 to the minus 1 of opposite side over adjacent side, so 30 over 60. You could do it as 30,000 over 60,000 if you want, or 3 over 6. So it's the 10 minus 1 of 0.5. So you'll get 26.6 degrees for that one there. So if you look at that, you could write that as east. Starting from the east, we're heading 26.6 degrees towards the north. So you could do it like that. You could do it in degrees true as well. You could start at the north and head around that way. This is your angle we're trying to put in there. So that's 26.6. How do you work out what this angle up here is, from north? You've got to do 90 take 26.6. So you've got 90 take 27 is 73, that's not 63, so it'd be 63.4 degrees true, starting at north and coming around clockwise. So what you've got there is you've got an angle, which we can put up here like this. If you want to draw it, 26.6 degrees, or you can give it as 63.4 degrees true. Both of those will work out okay. And you've got a side, so velocity. Okay, that's another type of question. Thank you.